This entire curve, this green curve, is telling you the number of machines added per worker. This red line is telling you number of machines need to be added per worker. At this point, the number of machines added per worker is equal to the number of machines need to be added per worker, and we call this as the steady state. Solow diagram. We have two equations up until now. If you have seen the earlier recordings, one is small y equals to small k to the power alpha. Alpha is lying between 0 to 1. This is the production function in the intensive form. In intensive form. And you have the another equation also. This is the first equation. And you have the another equation, which is k dot equals to s small y minus n plus delta small k. Small k dot equals to s small y minus n plus delta small k. So this is the key equation. Of Solow model. This guy is the key equation of Solow model, right? Acha, then before I just draw this, what are the parameters, what are the exogenous variables, and what are the endogenous variables? So let me write a point about them. So endogenous variables are those variables whose values are determined within the model itself. So endogenous variable. Endogenous variables, right? They are those variables whose values are determined within the, whose values are determined within the model, right? So, for example, in this case, small k, small y, these are endogenous variables, right? And parameters, parameters. Parameters are a given number, right? For example, small s, for example, alpha, for example, initial value of capital per worker, for example, population growth rate. These are the single variable and single values, right? They're not changing over time. Then you have exogenous variables. Exogenous variables. They can vary over time, but their values are determined outside the system. So for parameters also, the values are determined outside the system. For exogenous variables also, the values are determined outside the system. But in case of parameters, they are given. Exogenous variables, they can also increase over time, right? So they may vary over time. They may vary over time, but whose values are determined outside the system or outside the model, right? So for example, capital N. For example, capital N. So you should understand what are the endogenous, exogenous variables, and what is it, what are the parameters, and what you can determine and what you can't determine, and what is given to you from outside. So you know what is endogenous, you know what are parameters, and you know what are exogenous variables. Okay. Now, let us say I have this expression with me, this model. With me. And on the x-axis, I have small k, which is your capital per labor. On the y-axis, I have gross investment per worker, small s into small k. I think I have told you last time also. If you remember, we have sorry, this is small y. We have written S capital Y is gross investment and S small y is gross investment per worker, right? So this is gross investment per worker. Fair enough. And in the initial recordings of the Solow model, if you have been following this properly, then we have derived the production function like this. Small y equals to small k to the power alpha. So, and we have shown that this production function was concave, right? This production function was concave. One thing, let me just draw that production function again. And I have the function like this. Y is equal to small k to the power alpha, right? Now, I have y is equal to small k to the power alpha. Now, if I'm going to multiply this y with small s on both the sides, I get small s into k to the power alpha. Now, this s is a constant term. That is a savings propensity. It is lying between 0 to 1. So don't you think that this sy or s into small k to the power alpha term is nothing but the dampened version of small y? So this guy s small y is s small k to the power alpha. So S small k to the power alpha is the gross investment per worker. And this is a dampened version of y equals to k, small y equals to k to the power alpha curve. S small y is a dampened version of small y curve, right? S small y is the dampened version of the small y curve, right? Okay, it is, this curve is translated down by small s. That's it, by a factor of s. So please write this curve, means small s into small y curve, this curve is translated down by small s, right? Okay, then you have the another line, which is your n plus delta k line. N plus delta k line. This is the amount of investment per worker which is required to keep the capital per worker unchanged. We have talked about this, right? This is your replacement level of investment per worker, which is required to keep the capital per worker unchanged. And please write n plus delta k N plus delta K represents the amount of new investment per worker amount of new investment per worker required to keep the capital per worker unchanged. That's what it is. Your K dot is what? S small y minus N plus delta K, right? And replacement investment per worker is that. So everyone has, let's say, 5 units of capital per worker. And you have invested 10 units of capital per worker. But there has been the depreciation of the 5 units. So you are left out with only 5 units of capital per worker. So you're left out with only 5 units of capital per worker. So in order to keep the capital per worker unchanged, the amount of machines which you need to add to keep the capital per worker unchanged, that is what the replacement capital is. Because with a normal wear and tear, there is some amount of machines which are just get obsolete, right? So you need to invest again in that number so that capital per worker remains unchanged. So because if the number of machines getting obsolete are more than the number of machines which you add, so the capital per worker is going to fall. So if you want to keep the capital per worker unchanged, you have to add the number of machines also. And the point is, this is telling you, SY is telling you the number of machines added per worker. N plus delta K is telling you the number of machines need to be added per worker. So if the number of machines added per worker is equal to number of machines need to be added per worker to keep the capital per worker unchanged, you say small k dot is 0. If the number of machines added per worker are more than what is needed to keep capital per worker unchanged, then capital per worker will increase. If the number of machines added per worker is less than the number of machines need to be added per worker to keep capital per worker unchanged, capital per worker is going to fall. That's it, right? So this entire curve, this green curve, is telling you the number of machines added per worker. This red line is telling you number of machines need to be added per worker. At this point, the number of machines added per worker is equal to the number of machines need to be added per worker, and we call this as the steady state. You call this as the steady state where nothing is changing, right? Capital per worker is not growing. It is an equilibrium at this point. So when the number of machines added per worker is equal to the number of machines need to be added per worker, this is the steady state. But what about this point? Cannot. Here, number of machines added per worker is more than the number of machines need to be added per worker. So the capital per worker is going to increase. And it is going to increase till when? Till the steady state is reached. Similarly, here. Here, the number of machines added per worker is less than the number of machines need to be added per worker. So the capital per worker is going to fall. When capital per worker is going to fall, it is going to fall till when? Till the steady state is reached. That is at this point. So this is the steady state. This guy is the steady state. Although I'm not telling you about the stability, but if you look at it, this is a stable equilibrium. You start from anywhere, you are moving towards an equilibrium point. So this is a stable equilibrium. This is a stable equilibrium. You start from anywhere, you're moving towards this point. So you're starting from the left of the steady state, you're moving towards the steady state. You're starting from the right of the steady state, you're moving towards the steady state. So this is a stable equilibrium. What is an unstable equilibrium? You move away from an equilibrium. So if you start from the left, you move further away from the steady state. You start from the right, you move further away from the steady state. So that is what the unstable equilibrium is. But that's not what we are doing right now. I'm just telling you that this is the way you solve. This is the Solow diagram. And I want to tell you two more points. There is something which is called the capital deepening. There is something which is called capital deepening and something which is called capital widening. Capital deepening, right? Capital deepening. Okay. When the amount of capital per worker, amount of machines you're adding per worker is more than the amount of machines need to be added per worker, then capital per worker is increasing. So when this change is positive, you say that the capital is deepening. So every labor now has more amount of capital with him. When every labor has more amount of capital with him, when this change means when the number of machines you add per worker is more than the number of machines you need to add per worker, then every worker has more amount of machines with them. This change, this difference between the number of machines added and the number of machines need to be added, when this change is positive, when this change is positive, an economy is increasing. Its capital per worker we say that capital deepening is occurring. We say that capital deepening is occurring, right? Okay. Achha, there can also be the case that capital is increasing, but labor force is also increasing. Capital is increasing, but labor force is also increasing. And when with an increase in the capital, your labor force also increases. Then what happens is that there is no increase in the capital per worker. And that is what is called the capital widening. When every labor has more machines with him, that is capital deepening. Capital widening is that yes, capital is increasing, but at the same time, labor force is also increasing. So the number of machines per worker is not increasing, but the capital is increasing. So capital widening is this. capital widening, right? When the stock of capital is increasing, at the same rate as the labor force and the depreciation rate right? So this is what capital deepening and capital widening is. Capital deepening and capital widening is. So when you move from K naught to K star, right? Here in this diagram, this is the capital deepening case. That is, every individual has more amount of capital per worker. Every individual has more capital with him. That is the capital deepening case. So, beta, this is what I wanted to do in this class, right? Thank you, beta.